Welcome to the class of probability, one of the most interesting topic in general aptitude. In this topic specifically, we will be dealing with a lot of different words. But before that, let's try to see what is probability. Probability is nothing but possibility of happening or non-happening of things, events. So when we talk about this topic in particular, probability, we will come across words like event, outcome, result, possibility, happening, non-happening. Now, when I talk about probability, it means possibility of happening or non-happening of an event. Mathematically, probability is defined as NP upon NS. When I say probability is defined as NP upon NS, here NS stands for all possible number of outcomes, and NP stands for required number of outcomes. So for any question on probability, it will basically be solved using finding number of all possible outcomes and number of required outcomes. Let's try to see what all different pattern of questions that come on this particular topic, probability. In this topic in general, basic questions will be on specific concept of coins or dice or cards, but there is no restriction to only these three sections or these three topics. There could be a lot of questions on a lot of different topics. So let us start off with coin questions first. If I have one coin with me, can I say if I throw this coin, I toss it up, and when it comes down, I can have two possible outcomes, that is my NS is going to be 2, which is either I can get head or I can get a tail. Now the question that would come, or question that can come on this particular thing or this particular topic with one coin is probability of getting a head, one head. It will be given by NP upon NS. NP in this case is 1, NS is 2. Instead of one coin, if we have two coins with us, can we say possible number of outcomes when two coins are tossed would be head head or head tail or tail head or tail tail, which means the possibility, that is all possible outcomes, would be 4. Now what is the probability of getting exactly one head? It will be given by 2, that is this condition and this condition, out of 4. A question could be, what is the probability of getting at least one head? Now when I talk about at least one head case, it would mean it will consider all the possibilities in which there is exactly one head or there are exactly two heads. So out of the given 4 possibilities, the possibilities which are needed to be considered would be 3 out of 4. Hence probability of getting at least one head is 3 out of 4, and so on. Similar pattern questions will be coming on coins. Now instead of 2 coins, if I have, let's say, 3 coins with me, so can I say now arrangement or this when these three coins are thrown up, tossed up, possible outcomes could be head, 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 tail, head, tail, head, tail, head, head, or head, tail, 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 head, tail, 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 head, and finally tail, tail, tail. So when three coins are tossed up, NS becomes 8. The questions that could come on when three coins are tossed up could be probability of getting one head only, or probability of getting exactly one head. So for that, the conditions which would be considered 1, 2, and 3. 3 out of 8. Next question that could be asked would be probability of getting at least one head. Now the moment I say at least one head, it means we are going to consider the cases in which exactly one head has come out of the three coins, cases wherein out of three coins there were exactly two heads, and out of three coins all three were heads. So for the second question, probability of getting at least one head would be 1, 2, 3, 4, 5, 6, 7, 7 out of 8. Now let's go to the next type of question that would come into picture. Questions on the basis of dice. If there is one single die, it is called as a die. If I have one die with me and if I throw it up, I can get the outcome on the face as 1, or I can get the value on the face as 2 or 3 or 4 or 5 or 6. So I can say that NS in this case is 6. Now the questions that could come on this particular die topic would be probability of getting even number on the face. So probability would be 3 out of 6. Which are the three even numbers? 2, 4 and 6. What is the probability of getting an odd number? Answer would again be 3 out of 6. 1, 3 and 5. These are the three numbers which are odd numbers. Similarly, questions could be of the form probability of getting a prime number. So what would be the probability? It will be 2, 3 and 5. These are three prime numbers out of 6. What is the probability of getting a composite number? Now this probability is 2 out of 6, because from 1 to 6, 1, 2, 3, 4, 5 and 6, there are only two composite numbers, 4 and 6. So hence 2 out of 6 would be the probability of getting a prime number, would be a probability of getting a composite number. Similarly, a question could come in the form, what is the probability of getting a number which is a multiple of 3? What is the probability of getting a number which is a multiple of 3? So answer for this would be 2 out of 6. There are only two multiples from 1 to 6 which are multiples of 3. They are 2, 1, they are 3 and 6. Instead of a die, if we have two dice, then in that case the possible outcomes could be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on up to 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So NS in this case is 36. The questions that could come on this topic, specific probability questions on when two dice are there in this case, could be: what is the probability of getting both numbers as same? Both numbers as same. So it will be 6 out of 36. Which all are the cases? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. Similarly, there could be question like probability of getting both face values, both values on the faces as prime numbers. So it could be, again, let's try to calculate: 2, 2, 2, 3, 2, 5, 3, 2, 3, 3, 3, 5, 5, 2, 5, 3 and 5, 5, 9 out of 36. What is the probability of getting sum equal to 11? It will be 2 out of 36. Which are the two cases? 5, 6 and 6, 5 and so on. So similarly, there would be questions on 3 dice, 4 dice and so on. Now, before we go ahead with the next pattern, which is called as cards, I want all of you to understand a very important factor. When there was one die, NS was 2. When there were when there was one coin, NS was 2. When there were two coins, NS was 4. When there were three coins, NS was 8. Now, for one coin, maximum possible outcomes could be 2. When we take two coins, our possible outcomes become square of 2. When we take three coins, our NS, maximum possible outcomes, becomes cube of 2. So if we have 10 coins, our NS in that case will become 2 raised to power 10. Same is the case with dice. When we have one die, our NS is 6. When we have two dice, our NS is 36, which is 6 square. If there would have been three dice, NS would be 216, that is 6 cube. If there are 4 dice, it will be 6 raised to power 4 and so on. Let's move to card questions. All of us in our childhood would have played with cards. Basically, a pack contains 52 different cards. These 52 different cards are divided into 4 categories. They are called as heart, club, spade and diamond. Each of these types have 13 cards each. Out of these 13 cards, ace, king, queen and jackal, all these 4 cards are termed as face cards. Rest, cards which numbered 2, 3, 4 up to 9, they are called as numbered cards. Numbered cards. Now, if I have a well shuffled pack of 52 cards, questions that could come: I have a pack, well shuffled pack of 52 cards. So my NS in this case is going to be 52. And if I pick one card at random, what is the probability of getting that card as a red card? Now we know that out of these 4 different types, heart, club, spade and diamond, heart and diamond are red colored cards, whereas club and spade are black colored cards. So probability of picking a red card is 26 out of 52. Second question, that second format or type of question that can be asked is probability of getting a red king. Now we know that there are 13 red cards of diamond and 13 red cards of heart. Each of this, that is each of diamond and heart, has one king. So probability of getting a red king is 2 out of 52. Typically, third question could be: what is the probability of getting a black card or a black card or a red ace. This would be there are a total of 26 black cards and 2 red aces, so 28 out of 52. Next question. What is the probability of getting a king of black color? 2 out of 52. Now let's try to understand some properties of probability. Some properties of probability. First property, your probability can never be less than 0. It will always be greater than or minimum equal to 0, and it can never go beyond 1. So your probability always lies in a range of 0 to 1. Second property, probability of, let's say, happening of an event. Probability of A represents probability of happening of an event. So probability of happening of an event plus probability of non-happening of an event is always equal to 1. There are some events which are mutually dependent and there are some events which are mutually independent. So let's try to understand what will be probability for events which are mutually independent. These mutually independent events are also termed as mutually exclusive events. Let us consider you are right now in Bombay. You are a student of some engineering college in Bombay, and there is heavy rainfall going on in Chennai. Because of that rainfall, you are not attending the class. So is there any kind of a connect relation? No. Which means these two events are independent of each other. There is no relationship. So probability of happening of event A or B will be given by probability of event A plus probability of event B. But let's say you are a student of some college in Chennai and it is raining very heavily in your area. So these two events are dependent, because of which you're not attending the class, you're not going to college. These two events are mutually dependent events. Mutually dependent events are also called as mutually inclusive events. So when events are dependent on each other, let us say this circle represents probability of A and this circle represents probability of B, then probability of happening of A or B is given by probability of event A plus probability of event B. But in this process, the common region, common probability part between two probabilities is counted twice, so we need to subtract that part which is represented by probability of A intersection B. The next property that we need to understand is odds in favor of an event A are 3:4, which means probability or possibility of happening of an event is 3 and non-happening is 4, which means probability of happening of an event is 3 out of 3 plus 4. Chances of happening of event are 3 and non-happening is 4, so probability of happening of an event is 3 out of 3 plus 4, which is 3/7, which means probability of non-happening of an event is 4/7. Similarly, there is something called as odd against something called as odd against an event. Odd against an event B are 4 is to 5, so which means probability of non-happening of event B is 4 out of 4 plus 5, that is 4 by 9. So probability of happening of an event B is 5 by 9. These are certain basic properties of probability which we'll be using in this topic while we'll be solving some questions. Now if I say there is a bag which contains 7 green balls, 5 red balls and 4 orange balls. What is a probability if I pick one ball at random to be of green color? So probability of one ball being of green color will be given by, what is the total number of balls in this particular bag? 7 plus 5 12 plus 4 16, and there are 7 green color balls, so probability is 7 by